rather than emotions. We have 3 experts in the field to tell you different aspects of the sugar and health issue. The first of these is Denny, who is the Director General of the World Sugar Research Organisation. She trained in nutrition at Newcastle University in the UK and holds a Master's in International Nutrition from the London School of Hygiene and Tropical Medicine. Annie has worked in nutrition roles for over 20 years, spanning food industry, food retail, charity roles, and media work. She is a passionate believer in communicating science to individuals in an understandable language. At the Sugar Research Organisation, Annie's motto is, "Research isn't finished until it's communicated." Annie joined the research organisation as Director General in 2020. She leads a small team of nutrition scientists who research the latest evidence on sugar and health, keeping the members up to speed with scientific and health policy developments on sugar and health. Would you please welcome Annie to the podium?
So we see the notes as well, the notes page. Okay, hello everyone. Thank you for inviting me. It's a pleasure to be here. As Rod said, my name's Annie and I'm the Director General at the World Sugar Research Organisation. So before I start, if you're interested in health, can you stand up, please? So if health is something you're interested in. Okay, great. Someone not sure, a few floating at the back, doing some dancing, I think. Great, okay, thank you. Good. Okay, thank you. Just a quick request around social media. You're welcome to take photographs of slides for your personal use, but we do request not to post any slide pictures to Twitter or to other social media, just because of some of the scientific data from other researchers in my talk this morning. Okay, so just to tell you a little bit about World Sugar Research Organisation, we are an international not-for-profit organisation. We have 22 members across the globe in different countries. And our main role is to monitor the global scientific evidence on sugars and health. We're committed to improving the understanding of the role that sugars play in human nutrition, and we work to identify the scientific consensus and to find where the knowledge gaps are in the research base. We communicate this evidence-based information to our members in an understandable, non-technical language. So many of our members are non-scientists, so we try to make sure to make science understandable. In addition, we also support a small program of peer-reviewed transparent research, which we commission and fund also systematic reviews and other types of studies from recognized academic institutions around around the world. Okay, so I'm just going to give you an outline of the talk this morning. We're going to spend a minute reviewing why sugar has become so controversial. Then we're going to move on to look at what some of the dietary guidelines are and some of the recommendations for sugar intakes that Rod referred to this morning. And then dive a little bit into what the science says. I'm going to focus quickly on sugars and obesity, but of course there are many, many other health outcomes we could look at, including heart disease or, for example, whether sugar is addictive or not. So it's a huge topic to cover, and we haven't got time this morning to look at everything. And then I'm going to take you through what some of the challenges are in the sugars and health research base to help understand why this is such a difficult topic to really sometimes reach a consensus on. And we'll end up reviewing some of the most recent hot topics, so that's things like ultra-processed foods, the role of sugar-sweetened beverages, whether there's something different about those, and also low and no-calorie sweeteners, which have been a very popular topic in the media lately. And if we have time at the end, we'll do a very brief look at sugars and health policy and a moment to look into the future. Okay, so let's start by considering why has a relatively simple ingredient become quite so controversial. And with the rising tide of obesity, diabetes, and chronic disease, there has been a quest for dietary villains. Sugars received a huge share of attention, I think not least because compared with other elements of the diet, it's a component which can be more easily targeted in what we consume. But more recently, the dial has swung a little from fat. So those of you who remember in the 1980s, there was a strong focus on fat and the potential role of fat in driving the obesity trends, to sugars, and now more recently, I think, moving actually to looking at food processing and whether there's a role of food processing within this. So this chart just shows you the huge number of studies that have researched into the topics of sugars and health. You'll see that the interest in this area began in the 1960s, and it's increased exponentially, really, over the last 4 to 5 decades. And I think this is a research area which is likely to increase. Fortunately, at WSRO, we pride ourselves in being experts in helping our members to navigate some of this science and understand what the consensus really is and what the deal is around sugars and health. And here we have a bubble plot. Some of you may be familiar with these, some of you not, but this shows the very wide range of health outcomes that sugar's been investigated for. Essentially, it provides an evidence map of all the published studies which link dietary sugars with health outcomes. And on the map, we've got some of the more traditional topics, such as diabetes or heart disease or the role of sugars in body weight. But more recently, this map is being added to include things like COVID-19. So I'm sure you remember there was lots of questions around, was there any relationships, any links between sugars consumption and people's survival or people's outcomes from COVID-19? And in turn, looking at then the effects of sugars on immune health, because everyone became very interested in immunity and supporting their immune health in the COVID outbreak, and then in turn, the impact on the gut, because gut health is very closely interlinked with your immune health. So we see this chart being added to, and this is actually some work that this bubble plot was initially funded by WSRO in 2019 and conducted by Professor Mei Chung at Tufts University. So this increased focus on sugars and health has led to an increase in dietary guidelines across the globe, which recommend limiting the intake of sugars. These guidelines provide different definitions of the types of sugar used in guidelines, such as added sugars, total sugars, or free sugars. I've just picked out some here. You'll see on your right-hand side of the slide, we've got the American dietary guidelines. Those are updated every 5 years in the US. We've got the dietary guidelines for Indians and the recommended nutrient requirements for Indian populations. And then over on the other side, the UK SACN, which is the Scientific Advisory Committee for the UK government, their report on carbohydrates and health, which was very globally recognised as being a key source of consensus information. And I'm sure many of you will be familiar with the WHO guideline, and I'll talk very briefly about that. And at the bottom, you can see these definitions of free sugars. And just to give you an example, the definitions of free sugars do differ between the UK report and the WHO report. So this slide then gives you an overview of some of the recommendations around the world for general population adults. It shows just how many different recommendations there are, and therefore it gives you a sense of how confusing this topic can be. So when you see a story in the newspaper talking about whether recommendations for sugars are exceeded, which recommendations are we talking about? Which types of sugar are we talking about? Total sugars, added sugars, free sugars, if it's a comparison between 2 different countries, so does the US eat more sugar than in India, for example? We need to be very clear what we're looking at in terms of which definitions are being used, but also which set of recommendations. And I'll just draw your attention to the WHO, the World Health Organization recommendation, which is in the middle of the slide here from 2015. And this was the one that recommended that free sugars intake should not exceed 10% of dietary energy. So this is a recommendation you'll see used quite widely in, when people are talking about sugars and health. They also had a conditional recommendation of 5% of dietary energy. Remember that conditional recommendations are set with less certainty. So although this recommendation did come from WHO, it's only a conditional recommendation. Therefore, the certainty of the evidence for dietary sugars at less than 5% of overall energy is less certain. So what does the science say? I believe it's really important for everybody working in roles related to sugar, whether that sugar is a crop or whether you're involved in processing or refining, or whether even just as a consumer of sugar in our own diets, we should all have an understanding of what the scientific consensus is around sugars and health. This includes sucrose in the form of table sugar, but also other sugars such as fructose found in fruits or lactose found in dairy foods, because we need to remember that sugars are very widely consumed in the human diet in different forms. So just to give you a brief reminder of the facts about calories here that are found in the diets. I don't know if many of you will be familiar with this. If you've ever dieted yourself, if you tried to lose weight, you might be familiar with some of this. People always forget that alcohol actually provides 7 calories per gram. So if you are trying to lose weight, then alcohol is something for people to look at if you are a consumer of alcohol. Fat up there at the top with 9 calories per gram, protein 4 calories, and then the 2 carbohydrates at the bottom, starch and sugars are 4 calories per gram. And Julian Cooper will talk more about this later, but just to remind you all that all carbohydrates are broken down to glucose, wherever they come from in your diet. And glucose is, of course, the preferred source of energy for the body. So your brain needs glucose to function. And a teaspoon of sugar gives you 16 calories. Okay, so if we go on to look at obesity, this is where our role at WSRO really comes into play in working with our members in the sugars industry, because we help our members to understand the very complex scientific consensus on topics such as obesity. Overall, the nutrition landscape is characterized by a double burden of malnutrition. So we see around the world the coexistence of undernutrition along with overweight and obesity. And obesity is a very complex and multifactorial issue. This very complicated map on the other side of the slide shows this. This is the foresight map from a UK report, and the small area in green is food production and food consumption, and within that will sit sugars, but you'll see that it's only one part of a very complex map, which looks at things like individual psychology, the food environment, the physical activity environment, and other sociological and psychological factors which influence our likelihood of becoming obese. So what is the consensus of sugars? It's very much that the intake of sugars is a determinant of body weight. So as a source of energy in the diet, we know that how many sugars or how much sugars we consume is related to body weight in terms of energy. However, weight gain only occurs following an increased intake of sugars if diets are excessive in calories, so if diets are hypercaloric. So energy balance is really key here. And the changes in body fatness that really occur from a result of energy imbalance rather than any physiological or metabolic consequences of sugars per se. And beneath the map, you'll see this conclusion from the UK SACON report, which is that there is insufficient evidence to establish a direct link between sugars consumption and related measures of obesity. So it's very much to do with the calories consumed and when those calories are in excess, rather than anything metabolic to do with sugars directly. And a high sugar diet has also been linked with increased incidence of type 2 diabetes, and this is an area that causes much confusion because we do hear people say, well, sugars causes diabetes, and actually that's not true. Again, the intake of sugars is a determinant of energy balance, and therefore it's a determinant of body weight. However, you're much more likely to get type 2 diabetes if you're overweight. So again, as for obesity, there's no direct link between the consumption of sugar and type 2 diabetes. The effects are due to body weight rather than being directly due to sugars per se. And particularly for diabetes, factors such as genetics, diet, physical activity, and smoking status are very important in determining your risk of developing type 2 diabetes or not. And we've got many organisations around the world who have the similar consensus statements on diabetes and sugars, so the UK SACN, the World Health Organisation, EFSA, which is the European Food Safety Authority, Diabetes UK, and the American Diabetes Association, who all acknowledge that there's no direct link between the consumption of sugar and type 2 diabetes. And these charts really help to emphasize that. These charts at the top here are taken from the US, and they're mapping intakes of sugars versus obesity prevalence. So the one in the middle looks at intake of sugars, and as you can see, as the orange line for obesity has continued to increase since the mid-1990s, around 2000, intakes of sugars in the US have actually declined. The graph over to the right-hand side, the farther side, breaks this down a little further into looking at high fructose corn syrup, refined sugars, and total sugars. And you'll see when you split these out, you see a similar story that as intakes of these has continued to go up, obesity rates have not started to go down. So then what really is it? What is going on? We definitely know that reduction in intake of sweetened beverages has been advised around the world as part of healthier dietary patterns to reduce energy intakes, obesity, and obesity-related disorders. However, ultimately, there's a need to adopt a holistic approach that considers reduction of energy, so calories intake overall, and the wider dietary recommendations, rather than focusing singly on nutrients such as sugar. And that's particularly because there's strong socioeconomic differences in obesity. So we see wide health inequalities, with people struggling, particularly with poor mental health, being more likely to become obese, and people in lower socioeconomic groups also being more likely to become obese. So it's not as simple as just looking at single nutrient approaches. In my opinion, the 3 points at the bottom are really important to focus on overall. So that's calories, overall dietary patterns, and reducing sedentary behaviour being important in the prevention of obesity. And so science isn't clear-cut, unfortunately. With the increasing amount of research into sugars and health, the role of WSRO is more important than ever in helping members and others in the industry to make sense of science. Julian showed me a headline this morning, a paper that had come out in the UK this morning linking intake of free sugars with increased risk of heart disease. Many people will see that headline and they'll take that as being true. They'll look at the headline and say, well, that's what the study says, therefore that's what's true. Our job at WSRA is to do a deep dive and ask some questions about studies and really understand what's going on. This text is quite small, I'm afraid. You can't necessarily read everything. But to give you an example, when we look at a study that gives that kind of headline at WSRA, we will look at what was the strength of the evidence, how certain are the authors in the quality of that evidence and the strength of their findings. Was there a causal relationship? So did A cause B, or is it just an association between two different things? If it was a review study where studies have pulled together lots of different questions, lots of different studies looking at, say, heart disease and sugars, we'll look at which studies they included and which they excluded. Were they fair in that approach? Did they deliberately exclude some studies in order to perhaps skew their findings? And did we feel it was balanced? How was the sugar intake assessed? Because we know that people often underreport their sugars consumption. So if I asked you to tell me what you ate last week, you might not be entirely true. Not because you necessarily are embarrassed, but you may just forget. It may be as simple as not being able to recall that quick snack that you had on the way out the door. So we know there's high underreporting of sugars intakes in research. Who was the study done by? Was it done? Who was it about? Was it conducted in healthy populations, or was the research conducted in people who were already obese or who already had diabetes? Because that has strong effects on their findings of those studies. And the list goes on and on. Okay, so we're going to move on now from obesity and diabetes to take a moment to look at processed foods. So those of you who work in countries where the diets are more westernized might be familiar with some of these headlines. As I said, the dial is switching, I think, away from just looking at fat and salt and sugar on their own to considering whether there's something special about processed foods and how these affect our diets. You see headlines here such as processed foods are driving up rates of cancer, ultra-processed foods are linked to dementia risk, or that overall these foods are sort of have negative effects on our dietary patterns as a whole. And heart disease is another one that's being quite strongly investigated. So what do we know? We know that there is data to support an association between ultra-processed foods consumption and excess calorie intake and weight gain. However, the exact mechanism of action is really unclear. And this is an interesting research field. It's very new research at the moment, so it's not clear-cut. I can't say that we've reached a consensus in the scientific debate, but there is early research to suggest that what may be coming into play here is the rate of eating of these foods and the food texture, and that these two things may actually be more important than just looking at definitions of food processing. If any of you have heard the NOVA categorizations mentioned in the newspapers, that's to do with the categorization of foods based on their degree of food processing. So this is a study here. If you see the box on the left that's got the burger in it and the other plate of food, this is a study done by Kevin Hall's group in the US. And it's an interesting study in which they took 20 adults and they fed them 2 different diets for 14 days each. And these diets were matched for calories, they were matched for sugar, they were matched for fat and the micronutrients, so carbohydrates. So there was the same amount of fat, salt, sugar, carbohydrates in these 2 different diets available. But one diet was unprocessed, so based around whole foods, and the other diet was ultra-processed foods. And then they allowed these participants to select freely from these diets, and they followed them for a period of 14 days to see what happened. And interestingly, the participants on the ultra-processed diets ate around 500 calories a day more than those who were on the unprocessed diet. But interestingly, sugars intake was exactly the same between the 2 diets. And when they looked at what was causing the difference in that intake, why were they eating 500 calories a day more, it was mainly to do with the amount of fat and carbohydrate. So they were selecting foods that would have higher fat and higher carbohydrate content within these foods, and that was driving their 500 calorie a day increase. That then also led to a greater weight increase. So you see this chart showing how their body weight increased over this 14-day period following the ultra-processed diet. There were no differences in their self-reported appetite, so they didn't report being any more hungry or any more full on either of the diets. But really importantly, the ultra-processed foods were eaten more quickly. And this is where we think that some of this food texture and food processing might be coming into play. So it does appear at the moment that the soft texture of processed foods may lead to these foods being consumed more quickly, which leads to a higher energy intake. And if you look at those 2 pictures on the bottom, this is slightly different work here, but these are 2 diets, both matched for the number of calories. So both these sets of foods, it's not a very big picture, I'm afraid, but both of these have 1,575 calories in them, and you'll see that the unprocessed diet has a much greater quantity of food, whereas the diet on the left would be much faster to eat. And so looking at those 2 pictures, I think that's where we need to start thinking a little bit more about what we don't eat and how this focus on consuming too much salt, too much sugar, too much fat in the diet is possibly not very helpful. It's very negative messages to give to people. And people actually prefer to be given some examples of foods that they should consume more of. We all like to be told what we can eat more of, not what we can eat less of. So this chart here shows number of deaths and also the mortality rate, which is attributable to individual dietary risks from having diets high or low in certain things. And you'll see at the top that the greatest risks actually come from diets which are low in whole grains, low in fruits and vegetables, and low in nuts and seeds, and low in fibre overall. So I personally believe that what we don't eat is really important, and that fibre in particular has a very important role to play in the diet. But of course, without exercise, a good diet alone is insufficient, and eventually medical treatment will be needed, as Hippocrates told us. So it is obviously important also to remember not just to look at diets, but physical activity rates as well. Okay, so in the final part of the talk, I'm just going to spend a little time talking about sugar-sweetened beverages and then about low-calorie sweeteners. So this is a tricky topic, sugar-sweetened beverages, something that comes up time and time again. Is there something different about dietary sugars when consumed as a part of a beverage compared to when consumed as parts of foods? So sugar-sweetened beverage intake has been linked to weight gains, and it's possible this is to do with the fact that drinks may be less satiating. So they may have give us a lower sense of fullness compared to foods. We know that intakes of or high intakes at least, of sugar-sweetened beverages have been associated with overweight, obesity, and other chronic diseases such as type 2 diabetes, heart disease, and metabolic syndrome. It's important to note that sugar-sweetened beverages, like any food or drink that provides calories, can lead to weight gain if consumed excessively. So when you're looking at studies, at headlines around this, you need to look at what dose these were given in. And were the calories given on top of what the diet is normally, or were they given in exchange for? Because that's very important. Is this in hypercaloric diets where people are having more calories per day, or is this part of a balanced number of calories in the diet? It's also very difficult to disentangle the direct impacts of sugar-sweetened beverages on health outcomes. And that's because it's quite well known that people who drink very high quantities of sugar-sweetened beverages are often more likely to have other unhealthy lifestyle factors, such as low levels of exercise or quite poor dietary patterns overall. And when you're doing research into SSBs, it's actually very difficult to disentangle these and to appropriately control for them, so appropriately account for these things in research. Evidence also suggests that sugar-sweetened beverages do not provide the same sense of fullness, and therefore it's possible that people don't compensate for the calories, the excess calories that they consume from these. They therefore go on to have a dinner, say in the evening, and they have the same amount of calories at dinner as they would had they not have had the sugar-sweetened beverages. And lastly, whilst sugar-sweetened beverage taxes have been seen around the world to promote reformulation, there is currently no evidence to suggest that they have a direct effect on diet-related conditions such as obesity. And again, I think this is quite likely because of those other lifestyle factors that these very high consumers of sugar-sweetened beverages are likely to have. Okay, and just to finish up, we've got 2 minutes left in talking briefly about the role of low-calorie sweeteners. This, again, is a tricky one. There's been a big move to use these in the last 10 to 20 years, replacing sugars in products. However, recently the WHO has come out with its draft report on low-calorie sweeteners, suggesting that these products should not be used as a means of achieving weight control or as a way to reduce risk of diseases such as diabetes or overweight. And really here, I think it's about considering the role of reverse causality. So a difficult challenge in this area of research is whether actually people who have high intakes of low-calorie sweeteners consume those products because they are already suffering from obesity or living with diabetes. So it could be actually this idea of reverse causality, that it's not necessarily that the sweeteners are driving those conditions, as some of the newspapers are reporting currently, but it's just that those people who purchase these products were already living with diabetes or living with diabetes. So it makes this a very difficult research base to disentangle, and we're all waiting to see what the WHO says in its final version of its report, which is due out in April. And just to finish off, I like the statement here. It says that this public and legislative focus on sugar makes it even more important to understand where the public and politicians are. The attention is not going to go away. Indeed, it's only likely to grow. So I think there's much more work to be done still in the field of nutrition research when it comes to sugars and health. And my final slide will show you that certainly in the realms of food policy, there's a huge amount going on. And we've got things like the WHO's Sugars and Calorie Reduction Network. We've got things like front-of-pack labelling. And as I said, we're still waiting for the final results of the WHO report into artificial sweeteners. So we're all watching this space to see what happens. It's been a pleasure to talk to you today. We're going to take questions after the other 2 presentations, and thank you for listening.
Julian, who's an internationally renowned sugars and carbohydrate expert. Not bloody working. Righto. During Julian's 35-year career with British Sugar and AB Sugar, he developed extensive experience in process and product development, carbohydrate chemistry, and product reformation. He retired in 2015 and set up his own consulting company. He studied at Birmingham University, where he was awarded a Bachelor of Science in Chemistry and a PhD in carbohydrate chemistry. Julian has written many scientific papers and is the inventor of several patents. He has worked in major food companies, research associations and universities in Europe, North America, Japan, and has presented papers at many major symposia. He was Chief Scientist at British Sugar Technical Centre for up to 2001, and then Head of Food Science in both British Sugar and AB Sugar, with responsibility for new product technology development, external scientific research, health, nutrition and food law. He is a visiting professor at the University of Reading, a fellow of the Royal Society of Chemistry, and a fellow of the Institute of Food Science and Technology. Would you please welcome Julian?
Thank you, Rod. That was great timing. We actually got the system to work, so thanks again. And thank you very much indeed to the organisers of the conference for the invitation to come and talk. And thanks to Annie for setting the scene in terms of understanding the challenges we have within the sugar industry. Do we have the slides up yet? Beg pardon? Yes, sir. So, thank you very much indeed for the invitation this morning to talk on this. I'm going to talk about the challenge of sugar reformulation and give you some examples from the UK. In terms of the presentation this morning, first of all, we're going to talk about what's sugar. You may think that quite strange, talking to a group of sugar technologists focusing very much on cane sugar. I do hope you won't mind me being from the dark side, from beet, but we're all making sugar, so that's great. Look at what sugar does in food, look at the challenges of reformulation, look at what consumers expect, and that's important as well, and then look at some strategies to replace reduced sugars in foods, and then look at some examples from the UK where, in my opinion, they may well have got it wrong. So, what sugar? You may think that's strange talking to the audience we have today, but I'm a simple carbohydrate chemist, and carbohydrates, C's, O's and H's, as my colleagues used to say, or O's. They're defined by different units. So we've got the single units, we've got glucose, fructose, galactose. We've got the disaccharides, the one we know so well, sucrose, but also maltose and lactose. And then the carbohydrates themselves form the structures in plants primarily, and you're building up to smaller units like the oligosaccharides that have got 3 to 10 units. And then the major carbohydrates that are in the diet and in nature, the structural compounds in plants, the polysaccharides of starch, pectin and fiber. But when we talk about sugar, and people tend to use the term sugar to mean what we talk about sugar, granulated sugar, the sugar you see in the supermarket shelves and in your cupboards at home. But sugars are actually all mono and disaccharides. So when you look at an ingredient declaration on a pack, the sugars are all of the sugars from whatever source and not just sugar from sugar beet or sugar cane. Do indulge me as a simple carbohydrate chemist. If you want to be really flash, you can say today we learned about alpha-D-glucopyranoside, beta-D-fructopyranoside. I think that's why we call it sugar. The reason for putting this on the screen is really just to show you that you have two units of, you have a unit of glucose and a unit of fructose that make up sucrose. And one of the important bits is that little oxygen in the middle. When I started in the sugar industry, a well-experienced, for that read old, factory manager told me that we didn't make sugar at British Sugar. We just made sure we didn't lose it. The sugar beet had worked really hard to make it, and certainly the sugar cane works really hard to make it from photosynthesis. And the sugar manufacturer just makes sure you don't lose it. That little oxygen in the middle is really quite important because bugs love it, break it down to give you a mixture of glucose and fructose. Acid, it actually breaks down to give you glucose and fructose. That's important both in processing but also in food manufacture. So if you're making a soft drink, it isn't sucrose that's present, it's actually a mixture of sucrose, glucose and fructose. And more importantly, it's important in nutrition because that molecule is too big. The more observant of you will recognize that my company is called 342 Consulting. 342 just happens to be the molecular weight of sucrose. In your body, it breaks down to a molecule of glucose and a molecule of fructose, which can then get absorbed into your body. So that little oxygen in sucrose is really quite important. If we move on a bit to functionality of sugar, what does it do? What does it do in products? We know more or less what it does within our manufacturing process, within the cane process or within the beet process, but you probably don't understand a lot about what it does in products. So just spend a few minutes to talk about the functionality of sugar. One of the areas that is important in sugar processing is solubility. We all realize that if we want to get crystal sugar out of a masquit, you have to get the solubility up. It's saturated at 67% at room temperature. Higher temperatures, it will be more soluble. If you take a hot solution and cool it down, we all know what happens. You get the sugar that's crystallizing. That's important in the sugar manufacturing process. It's also very important in certain sugar products. And actually, this stabilization or unstable systems within products can give you crystals in the food product, so things like fudge. And also it's important in chocolate to get the crystal size right, so you get the right texture and the right mouthfeel. Another important factor associated with solubility is food safety. Many people don't realize that sugar is very, very soluble. Bugs don't like high concentrations of sugar in solutions, and therefore it acts as a natural preservative. If you start to reduce that, it can have impacts on food safety, and I'll cover that a bit later in my presentation. Some of the other areas we want to look at are the structure. Sugar, because of its solubility, it reacts with the other ingredients that are present in a food to actually give you structure. So the structures in cakes and biscuits, cereals, confectionery are provided by sugar and its interaction with the other materials that are present, the starch, the proteins, the fat. It provides the texture in products. So in fact, the particle size that you use is really quite important. It gives you the texture in fudge. It also gives you the snap in biscuits. If you're manufacturing biscuits on a large scale, if you have a range of particle size within your sugar, your biscuits spread too wide and you can't pack them all in the same packet. It's great if you're making your biscuits at home, but the manufacturer wants uniform biscuits that will pack on an automatic machine. So getting the particle size right in sugar for manufacture of biscuits is really quite important. Colour and flavour is really quite important as well. The traditional flavours we get in products are associated with the breakdown of sugars, and that's particularly glucose and fructose. Both of those are reducing sugars and react with proteins to give the characteristic flavors that we know in products. So baking and confectionery, you get that traditional caramelly notes. Those are really quite important. If you change the sugar, you can get different flavors. So if you use 5-carbon sugars, for example, xylose, when that reacts in the Maillard reaction, you get meat flavors. Totally different from the hexose sugars, the 6-carbon sugars that we use and manufacture from beet and cane. One of my favorite applications, and as Annie rightly pointed out, alcohol unfortunately has 7 calories per gram, so don't overconsume that by any great extent. But to actually make that alcohol, yeasts break down the sugars, and that's both sucrose. The first thing it does is invert that sugar to give you glucose and fructose, and the yeast will then use that sugar to produce the alcohol and carbon dioxide that we find in a lot of products, for example, bread and beer. The preservative effect is really quite important, and people underestimate that at their peril. It dissolves very, very readily. It gives you a high osmotic pressure. It's broken down as you make jams and preserves because you tend to add in acids, so you end up with a mixture of sucrose, glucose, and fructose. The preservative effect is based on what are known as colligative properties, which are the numbers of molecules that are present. So say, for example, you have glucose, one molecule, sucrose, you have one molecule. If you break that down to give you glucose and fructose, that gives you two molecules, so you actually get more bang for your buck with glucose and fructose. It extends the shelf life on products and gives you the food safety that's necessary as a preservative. The one area that we're probably well familiar with is sucrose. It's the standard, it's the gold standard at which everything is compared. And all the sugars and sweeteners are compared to sucrose. For example, fructose is slightly more sweet at about 1.2. The actual sweetness depends on the concentration and also the acid level. Glucose is less sweet, lactose even less sweet. But the profile of sweetness is just as important, and that's why when you're dealing with high-intensity sweeteners that are many hundreds of times sweeter than sugar, you actually have to blend them to get the right profile of sweetness and not just the absolute value. If we look at what's driving reformulation, in Annie's presentation we heard about obesity and all the other non-communicable diseases that are in which sugar is implicated. It's down to calories. But people are trying to remove sugar from their products. They're trying to cut it back, and that might be down to drivers from drivers from government, consumer groups. The consumers themselves want to reduce their sugar intake. So the poor old new product developer in the middle has to first of all abide by the regulations, what it can and can't put on a label, look at the additives, look at the health claims it wants to make. The regulators say, oh, we're bringing in a sugar tax so you can actually change your product. We want you to reduce sugar in products to protect the public. The consumers are looking for healthier foods. They want choice and value, but they also want a clean label and they want good taste. And the poor NPD developer in the middle is having to protect the brand that's associated with its company, look at the innovation, and bring increased sales and increased shareholder volume. And then it also has to satisfy the marketing organization that want to make no end of claims about products. Consumers, and I did some work at Leatherhead Food Research in the UK. We used consumer focus groups and web-based questionnaires. They had a good awareness of no added sugars claims and reduced sugar claims, but they didn't actually understand the level of reduction that was associated with these claims. They looked at sugar, and in this case they primarily looked at sucrose, granulated sugar, because they thought that's what was in all the products, even though it wasn't. They were looking at sugars as a proxy for calories. Therefore, if they saw a reduced sugar claim, they expected a reduction in the calories. And that's really quite important because a lot of these products don't deliver that. If we look at the challenges, well, we're looking at multiple ingredients. You have to use a lot more to get the benefits for sugar. Your increased labels and warnings. You have gastrointestinal consequences. I apologize for raising that coming close to lunchtime, but we'll go on to that. You'll understand I talk a lot about sugars and gastrointestinal health. Your food safety may be compromised. As I mentioned earlier, sugar provides a natural preservative. There was an instance in the UK where a hazelnut puree was being made to put into a yogurt, and it contained sugar. Sugar at the time was quite expensive, and the low-calorie sweeteners were cheaper. So they replaced sugar with aspartame. What they hadn't realized that sugar was acting as a natural preservative. And as a result of that, the hazelnut puree developed botulism, and basically one person died, 27 people were put in hospital because sugar had been replaced by aspartame because they hadn't realized the impact of that food safety hurdle. And that's an important element that people forget. Reducing sugar may increase calories, we'll come on to that one in a bit, but also the taste and consumer acceptance are really quite important. So what can I use? If you're looking at sweetness, we've talked about high-intensity sweeteners. You can also use polyols. Polyols are basically hydrogenated sugars. Many of you will have heard of sorbitol or xylitol. Those are just the sugars that have been hydrogenated, the same way as you make trans fats, basically, and hydrogenate fats. You need something to provide the structure, so you're looking at bulking agents. You need to provide the color that we get from the Maillard reaction with sugars. You also need to add in flavors. If you're not putting so much bulk in there and the sugars that are soluble, you have to put in preservatives. And you then also have to add in back some of the moisture you want, the humectancy in products. So, what sort of strategies could someone do to actually take sugar out? They're saying that sugar's bad for you. So obviously, if you take the sugar out, it's got to make the product more important. So, you could just take the sugar out and add nothing. That would work, wouldn't it? You'd actually reduce the calories. You could gradually reduce the sugars, just rather imperceptibly to the consumer, just gradually reduce that, and they wouldn't notice the difference. You can change sugar in its structure and properties. You can make it more effective. You can add sweeteners. You can add polyols, but you also then have to add warnings. You can add everything. In the UK, we would call that adding the kitchen sink. You add the whole lot. So, this is an example of a breakfast cereal. Big labeling flash on the pack, 1/3 less sugar, nothing added, just sugar taken away. So this is a sugar-coated product. For those of you that know the UK cereal market, these are sugar frosties. You have a calorie content there of 371 calories. The reduced sugar product, which has got 30% less sugar, 1/3 less, nothing added. It's got less sugar, yes. It's got more or less the same calories, 369. If you take totally nude Frosties, i.e. cornflakes, where you have not added the sugar, you end up with 373 calories. So you actually get more for less sugar. And this is an example you will find in other products. You can do a stepwise reduction. You can actually start off, and people would say, oh, look, I start off with, this is a shortbread recipe, which just contains butter, flour, and sugar. As you take the sugar down, so you go from 50 to 35, you're going to get calories, aren't you? You're going to get a reduction in calories. But when you actually look at the product, and normally I would actually go through this product and give you a nice stepwise change. I put this in front of some of the action groups, and they get really annoyed at me for putting this up because they advocate a stepwise reduction, and it doesn't flipping work. So we'll just bypass this one if it'll let me. Let's see how we go. I would normally just put this up and do it in real time, and they get very annoyed at me for doing it. But basically, the results you get. So you're starting off at 50, going down to 35, and your calories go from 463, and they go up to 466. And people will say, why is that? You're taking sugar out. Why are my calories going up? Well, in fact, what you're doing is you're actually increasing the level of fat. And if you remember from Annie's presentation, fats are 9 calories per gram. So you're taking out something that's 4 calories per gram, 9 calories per gram goes up, your calories go up. So you're reducing sugar and you're getting an increase in calories. You can change the properties. This one's actually a superb piece of science done by Nestle. They actually changed the structure of sugar. They used special ways of restructuring the sugar to give you hollow spheres. So you actually had the sugar on the outside of a sphere. Unfortunately, as scientists, they didn't realize the spheres contain nothing, air, and last time I looked, air doesn't weigh much. So when they actually made their chocolates, they were able to make 30% less sugar, but when you looked at the calories, you got only a 3% calorie reduction with all this amazing science. So again, not really a good way to reduce your sugars in a product by putting an awful lot of science into it. The classic way, which everyone speaks, and is a very, very successful reduction in sugars, and it's been happening in the UK since the 1990s. There's nothing new about reduced sugar drinks, certainly on the supermarket shelves. These are some typical soft drinks you may get at the supermarket. You ask the consumer, most would say those are full sugar. It doesn't say anywhere on them diet or reduced sugar, excuse me. But when you actually look at the labels, and I'm sad, as a scientist, I read labels. And when you look at the labels, there's only really Coca-Cola that is still full sugar at around about 10.6 grams per 100 mils of drink. All the others, even the famous brands like Schweppes tonic water, like Sprite, like Our White's lemonade that are famous in the UK, they contain low levels of sugar relative to a regular drink. The soft drinks industry levy, everyone calls it the sugar tax, was aimed at trying to get a reduction in sugars in soft drinks. A lot of the reformulation were just tweaks to the side. For example, if you look at Schweppes tonic there, it's 5.1 grams of sugar. The threshold for the soft drinks industry levy was 5 grams of sugar. So what do you think the concentration is now in Schweppes tonic water? It's 4.9. So they just dropped it down a little and yet claimed an awful lot. So again, you have to be careful on the headlines. It works really well in soft drinks to use high-intensity sweeteners because they are 200, 300 times sweeter than sugar, and you're replacing that bulk of sugar with water. If you have a solid product, the same is not true. This is actually a cake. It's basically what's called a pound cake. Same concentration or same weight of fat, sugar, flour. I've omitted the eggs off the recipe because it makes it easier for me. And the calorie-reduced cake was using a calorie-reduced ingredient, in fact, one that was developed by Silver Spoon in the UK, which is part of Associated British Foods, where 50% of the sweetness came from sugar and 50% came from low-calorie sweeteners, high-intensity sweeteners. Put the two together, and you could use half a spoon and get the same sweetness. So you would think you would get a calorie reduction. However, you also get a smaller cake. So when you look at the calories per 100 grams, you're using a low-calorie ingredient and you're getting an increase in calories. Consumers can't understand that. They can't understand why, using a low-calorie product, they get an increase in calories. You can add polyols, and this is an interesting one. Maynard's wine gums, I'm not sure if they are present in India, but certainly in the UK they are a big market leader. They made light gums. They actually replaced the sugar with sorbitol, a polyol. So on the label it said, reduced sugar sweets are made with sweeteners. If you eat too many, it might temporarily cause you mild stomach ache or laxative effects. We really want you to enjoy these sweets, so suggest you only eat a few at a time. Have a guess where these were sold. They were sold in motorway service stations, so you could pick them up, sit in the car, and then have to try and find the next service station so you could relieve yourself. So again, it's really good marketing ploy. Eat this, it will give you diarrhea. Not amazing marketing in my view. You can throw the kitchen sink at it. When I make jam, I take fruit, I take sugar, I take maybe lemon juice or citric acid. I might add a little bit of pectin, stew it all up, and I get I get jam that I can store quite readily, high concentration of sugar, good storage. Sugar-free preserve, you add in water, strawberries, polydextrose, maltodextrin, locust bean gum, natural flavour, citric acid, potassium sorbate, sucralose, calcium chloride, and a colour. They are all performing different functions that sugar does as a multifunctional ingredient. You can't even call it jam. You have to call it a spread or a sugar-free preserve. So again, a consumer will look at that and say, well, I can't even say some of those things that are on the label, let alone understand where they're from. This one is one of my favorite ones. These ingredients, you don't have to read all the ingredients. It's basically, the declaration on the pack should be thickened water with colors, flavors, sweeteners, and preservatives, because that's what it is. There's over 8 additives in that, and that is sold as a sugar-reduced product. Not really the sorts of things I would want to eat. Ultra-processed, highly processed. It might not have a lot of calories, but it doesn't taste particularly good, and it's not nice to look at. So essentially, what we're looking at for me is actually sugar. It's natural, traditional. It's a multifunctional ingredient. What you have to recognize is that sugars, when you see that on a nutritional label, it's not just sugar that we would make in a cane factory or a beet factory. It is all the other sugars, and that little s is really quite important. There is no unique sugar replacer that you can use in all applications. There are impacts on clean label, additives, safety, cost and taste, and that's the final criteria. A lot of the products I have shown you today are no longer on the supermarket shelves. I'm sad I read labels. I also collect labels, and I also collect products that try to replace sugar in products and don't deliver. And a lot of these products have not delivered. They are also a lot more expensive, anything up to 50% more expensive. So in my opinion, reformulation is not the universal panacea that everyone claims it is. It should deliver improved nutritional profile, and ultimately it should deliver a reduction in calories. If it does that, I'm happy. I would just highlight some new challenges for sugar, not just the calories we've talked about today. More and more of the sugar replacer companies are now challenging sugar on sustainability, on water use, on greenhouse gases. There's one particular company that are using cane processed juices to make rubidioside M, which is one of the components in steviol glycosides, which is a high-intensity sweetener. So-called natural, but they're now making that by fermentation from sugar juices and are then knocking the sugar for having a greater environmental impact. So that's going to come along where people are looking at how it's made and challenging sugar in other areas. So that's just a head up for new challenges. That concludes my presentation. Thank you for your attention this morning. Thank you.
Thank you, Julian. Our next speaker is Dr. Gillian Eggleston, born in Blackburn, Lancaster in the UK, received a Bachelor of Science in Chemistry and Biochemistry in '84 from the University of Nottingham in UK, and a PhD in '89 in carbohydrate from technology. Also, we seem to be having a lot of input from the UK today. Dr. Eggleston has worked internationally in the field of carbohydrates and industrial sugar and bioproduct processing. In 2018, Julian became the director and full processor of the Audubon Sugar Institute, part of LSU Ag Center in Louisiana. Before that, she spent 24 years leading the sugar crop processing at the USDA Southern Regional Research Center in New Orleans, USA. Research has resulted in over 427 publications and 36 national and international awards. Dr. Julian Eggleston frequently gives international keynote, plenary and workshop presentations and consults extensively worldwide. She has mentored young and older scientists, as well as visiting scientists, postdoctorates and graduates from all over the world, and served as external reviewer for 7 PhD degrees. Please welcome Dr. Eggleston.
Thank you. It's a pleasure to be here. I'm particularly pleased to be in India for the first time, and I thank everyone here for the welcome. Thank you for inviting me on this panel. This is a subject I've been talking about for the last few years, and I'm very passionate about it. You've just had 2 British speakers, and you're going to have another British accent, but I'm going to be focusing on the USA, where I've been for the last 30 years. So I'm going to talk about the case for natural, nutritious, and functional sweeteners from sugarcane that meet new consumer demands. The outline of my presentation, we're going to first talk about these changing consumer demands, and Julian just mentioned that a little bit. And consumers are demanding more natural sweeteners. And then we look at sugarcane, how it can fit this niche natural, unrefined, and less processed sweeteners from sugarcane. We'll then move on to the nutritional value of these products and compare them to other natural sweeteners on the market. And finally, I want to wrap up by considerations for future marketing of cane products. So current consumer demands for food and sugars are changing around the world. In particular, this is being driven by younger people, especially those born in the early 1980s to early 2000s. And you see them, obviously, they're greatly familiar with the digital communications, with social media, and they're demanding more things. They're asking for natural and healthy foods. They want them produced and packaged sustainably. They want them transparently and clearly labeled, and they want to have short and understandable ingredient lists. Here is some results from top claims for beverages in the United States. And you can see allergy, gluten-free was high. That doesn't apply to sugarcane. Organic is high, but so is natural and antioxidant content, and I'll be mentioning that later in my talk. And natural sweeteners are essentially a part of this demand, and their utilization is rising at an unprecedented rate around the world. Ironically, this consumer-driven trend is actually starting to redeem sugarcane and sugar because sugarcane is a natural plant. We've got a natural product. Now, I want to make something very clear at the beginning. The definition of natural is not, there is not a clear consensus for this around the world. In fact, currently, the Food and Drug Organization of the United States government, because of this, they've refrained from defining natural. Here is some work from Lusk that was published, where they looked at the perceptions of food consumers and purchasers in the USA, and what did it mean to be natural? And there was, as I said, no consensus. Most consumers checked at least 3 out of 11 possibilities. And you can see here, no preservatives is high, no pesticides, organic is quite high, and few added ingredients. And as Annie was saying earlier, we all know about the demonization of refined white sugar. And as she explained, mostly for its calories. But this is even though we have the sales of sugar still increasing globally. It's still the most widely used sweetener around the world. And consuming excess calories from all sources and sedentary lifestyles are contributing more to obesity, and I think Annie did a good job explaining that. Additionally, sucrose remains the gold standard for sweeteners. This is basically all the different functions, and Julian has already gone through a lot of this. It's a remarkable compound is sucrose. It's very stable. It sweetens, but it's got all these other functions. It's particularly a bulking agent in foods, a preservative, a color agent. It actually masks bitter and off flavors in many foods. It's needed for that. It's an energy source, readily fermented, delays discoloration, and also it's even important for decoration. Sparkling crystals, desirable surface cracking. But I think one of the most important functions is the bulking and texture addition to foods. And if we look here at the criteria for an ideal sweetener, what was so interesting was most of the criteria, it's all related to sucrose. It's got to be at least as sweet as sucrose. It's got to exhibit the bulking properties of sweeteners. I'm not going to go through all of them. The more the sweetener tastes and functions like sucrose, the greater the consumer acceptability. It has to be processed much like sucrose with existing equipment, and that's more desirable to industry. It's got to be water soluble, stable, long shelf life, all these things. And because of none of these new sweeteners, as Julian was saying, none of them are able to give or impart all of these different functions of sucrose. So if I hope you come away with anything today, is realizing sucrose is not just a sweetener. It's a very versatile compound. It's got multifunctions. And this is just explaining what Julian was saying. You can see stevia has to be mixed with erythritol. Truvia, they're mixing it with brown sugar. So none of these different new sweeteners, they can't replace this versatile compound, sucrose. So this increased consumer demand for more natural sweeteners is causing two great impacts. We're seeing increased marketing and consumption of alternative sweeteners, natural sweeteners, sorry. We're seeing honey, powdered honey in the markets. Powdered maple sugar, which is more pertaining to Canada and the USA. Powdered date sugars, powdered coconut sugars. That is not the pith in the middle of the coconut, that's the sap from the tree. And at the same time, we're seeing a growth for unrefined, less processed and natural cane sugars from sugarcane. So we're seeing the organic sugars, the different colors of brown sugars, the non-centrifuge sugars, and the golden sugar. So how are these brown sugars made? There are two different ways. The traditional method was to use a low purity processing liquor, crystallize, and you centrifuge and you end up with your brown sugar. But for many years now, they're using basically white sugar and coating it with different levels of molasses or refined syrup, and in this way you can control the product. You can make sure you have the same brownness in the product. Quality control is improved. And then, of course, we have the less refined non-centrifuge products, which are also known as non-centrifugal sugars by the FAO of the United Nations. And we are in the land of jaggery. So obviously, huge amount produced here in India, but we have many other of these products around the world. For example, panela, piloncillo in Latin America. And actually, some of these are known as medicinal sugars because of their health properties. Organic sugar is really increasing around the world, even though it costs more than conventional sugars. And that's because the sugarcane has to be grown carefully without synthetic herbicides and pesticides, without synthetic processing aids. So it's more expensive, but it's really increasing to the point in Europe, the demand is so high, they can't fulfill the demand and they're having to use domestic sugar beets for that. And then recently, I was very pleased to see this in the US markets last year. We have a new product called golden sugar. It's centrifuged. It's by a large refinery company. It's actually an industrial refinery company. It was launched in the States in 2021, but previously it's been launched in the UK and Canada. And I spoke to the technical manager of this company, and he said it's all because of this new consumer drive. The consumers are looking for cleaner, more natural, less processed foods. This is golden sugar. It has the same calories, but it can be just used as refined sugar, a one-to-one replacement. And it has slight nutritional benefits, which I'll show later. And this is what we're seeing in the States. We want white sugar because it's like a blank check. When you sell your white sugar to a large cake-forming confectioners, they know what they've got. They can add their own flavors and their other ingredients. But what we're seeing is a change of specifications. They're asking for, it doesn't have to be as white as it used to be. It can be, the particle size can be a little more variable. So this is the movement we're seeing in the United States. Now I just want to go a little bit to the nutritional value of natural and refined and less processed sugars from sugarcane and compare them to other natural sugars. Here's the typical composition of cane sugars. So you can see we have the refined sugar, and you can see a lot of the minerals and the vitamins have been removed. Where brown centrifuge sugars were at 80 to 95% sucrose purity, it does contain some minerals and some vitamins, whereas the non-centrifuge sugars, such as jaggery and panela, are obviously less sucrose, but very high amounts of minerals and vitamins. And the other thing that we really got in sugarcane, it's the sugarcane stalk is full of natural phenolic compounds, flavonoids and phenolic compounds. They're mostly the natural colorants in the cane. They go right across the processing and they end up in the raw sugar. And these have antioxidant properties, such as antioxidants. They're meant to help with immunology, anti-inflammatory, anti-carcinogenic. And what's interesting is a lot of these sweeteners on the market, so we have Equal here, stevia, they're actually adding antioxidants. They're having to add antioxidants and they're marketing it for this. Whereas cane already has our own natural antioxidants, and we're not taking this into account enough, I think, when we're selling the sugar, that we have natural antioxidants. Now, I'm not sure if this is allowed in all countries, but it is going on in the USA. If you look at the phenolic compounds, we can measure the total phenolic compounds. It's in the juice. Obviously, cranberry juice and pomegranate juice is super antioxidant-rich juices. Cane is less than that, but it is on par with apple juice, pineapple, and orange juice. But what's interesting is molasses is on par. It does have the same phenolic and antioxidant properties as pomegranate juice. But the problem is too much molasses becomes laxative. I also want to point out here, hopefully, if you look, we're taking all the phenolics out in the white refined sugar. We get the less refined it is, the more brown, the more phenolics we have, the more antioxidants we have. So then we also looked at natural sugars as well. Here's our cane sugars. This photograph isn't the best, but the one thing I noticed was the cane sugars are very nice, light crystals, and all these other solid sugars from different natural sources, they're made as amorphous masses and then they're milled. So just looking at them, they're not as attractive as the cane sugars. If we look at some of the nutritional values, so I've done this in colors, so we're going from white to very dark, and the ones with the red arrow are the actual cane sugars. So obviously your white sugar has very little phenolic, very low color, very little antioxidant capacity. The reason we use two values for antioxidant, the reason you pick this up here is sucrose and glucose and fructose have their own slight values as well. Margaret Clark of the Sugar Processing Research Institute showed that about 30 years ago. And as this is the golden sugar, slightly more color, more phenolic compounds, slightly better antioxidant. And you can see maple sugar, pretty good color and phenolic, but I don't think maple sugar is going to be very interesting around the world. But if we look at the coconut sugar here, cane sugar is doing just as well, if not better. Same here. Date sugar was very dark, very high in phenolics, but the problem with date sugar, it was insoluble in some of the recipes. So I don't think it has all the functions you need to replace the cane sugars. And then here you have the non-centrifugal sugars, which are very high in color, but they're very high in phenolics and antioxidants. The other main issue about all this is when I put all this in US dollars per ounce. Here's the refined cane sugar at 16 US cents per ounce. Golden sugar is 0.17 cents. You can see the brown sugars here at 23 cents per ounce. Jaggery and panela were higher because they're imported into the US, but actually here in India they'll be lower. And then you compare with these other natural sugars and they're really quite expensive, much more expensive than the cane sugars, and the same with the stevia. So cane sugars are equally as nutritious and, the brown sugars, the golden sugars are equally as nutritious as the other natural solid sugars and some of the replacement sweeteners, but they're a lot less costs. And this isn't just applying to the United States. I was in the UK. I saw the same thing there. That here we have the coconut sugar, 96 cents per 100 gram, whereas your castor sugar, much less. Here's your brown sugar, slightly higher. So I don't think this is just a phenomenon in the United States. Now, I just want to mention the future. I don't think, as an international industry, that we've done enough to counteract this negative publicity for sugar, especially as the more I looked into the research and everything. What a versatile compound. It's the gold standard for sweeteners, not just because of its sweetness, for all its functions. And it doesn't cost as much. I think there's a lot we can tell consumers. And here I just wanted to show you, this was in the US, this was by the Egg Board of the United States. They did a very good campaign. And they showed here, they had foodstuffs, a cake, and little bullets here showing what the eggs was doing, what the egg was doing to the function of these foods. We could easily do that for sugar, even refined sugar. Here, we add bulking capacity to the cake, we add moisture to the cake, and we're adding colors. If we added brown sugar, we could maybe say we have natural antioxidants. We're adding slight flavors that might be positive for the consumer. We're adding structure. And finally, I just want to highlight there are some areas in the world where we are trying to get this information over to consumers. We have the Sugar Association in the USA. I know Annie works with them. We have a National Real Sugar Day. We could have a National Natural Sugar Day. These are all things that are really food for thought here today. So finally, in summary, I just want to say in the USA and other countries, consumers want more natural foods and ingredients, and consumers are getting more familiar with antioxidants, and we are rich in antioxidants. Sugarcane brown and unrefined centrifuged, non-centrifuged, and organic sugars, they're rich in phenolic compounds and natural antioxidants. Even more so, they're less expensive to manufacture. I think this gives the cane brown sugars, less processed sugars, an edge in an already competitive and fast-growing natural sweetener market. Finally, comprehensive educational and marketing campaigns by the international sugar industry are needed to inform consumers about the natural, highly functional, versatile, and nutritional value of cane sugars. So thank you so much for inviting me, and thank you for listening.
Thank you very much for that presentation. We now have some time for questions. And before you stand up, there are a couple of rules you need to observe. The first one is wait for a microphone before you ask the question. When you ask the question, keep it short. And can I ask you to speak slowly so that we can understand you and answer the question correctly? Thank you. So who wants to ask the first question?
Thank you. Three great presentations with compelling insights. A couple of months ago, there was research reported by Harvard University, the Wyss Institute, which was funded by the food giant Kraft Heinz. And basically, they engineered...
Arvind, we're having trouble hearing you.
Okay, take two, right. Take two. Thanks again for all the presenters for compelling insights in the presentations. Couple of months ago, researchers at the Harvard University at Wyss Institute, funded by Kraft Science, the food giant, engineered enzymes which convert sugar in the gut to fiber. And the enzymes could also be formulated in recipes without modifying the sugar content. So at the risk of being rhetorical, Julian and Annie, is this the philosopher's stone that the industry has been looking for?
Is this working? Can people hear? Yep, thank you. Arvind, good question. Interestingly, how do you ensure that the enzymes stay in contact with the sugar when it's going down through your gut? You eat it, you chew it up, the enzymes in your saliva break it down, the acid in your stomach breaks it down. Is it going to form fiber in the stomach or actually further down the GI tract? What are the side products? What about the allergenicity of the enzymes? It's great. It's a bit like the Nestle crystallized sugar. Great in theory, in practice, I can't see it working personally. I think there are some good benefits in getting certainly oligosaccharides, and certainly several of the beet sugar companies are looking at producing prebiotics, which is basically food for good bacteria that goes down. It's like Christmas lunch for good bacteria, ends up in the colon, and you then proliferate the good bacteria. So again, sorts of things. I personally don't think this one will work, but it's an interesting one. Thank you.
Another question?
Very nice presentations, but I'm afraid what the sugar industry will do. Should we grow the industry? Because the sugar, earlier we used to have this brown sugar with the ghee in a bowl, and used to eat heavy quantity of brown sugar with ghee, and just to have nutritious body and all that. Now with these conditions, as we are doing, this tobacco is injurious to health, leveling is there. Smoking is injurious to health, we are mentioning on levels. Should you mention sugar is injurious to the health? Is it so? Because there was mentioning that leveling should be there on the packaging. So should we mention sugar is injurious to the health? So my request is that all these points, what we have presented, very, very useful for you people, and we need awareness for ours and for our younger generation. Because our younger generation is using Coca-Cola and what cold beverages are normally they are using. So your presentations will have the effect, but we have to grow with the sugar industry also. My request that your awareness shall be useful to us, and we are thankful to you also, to you people. Thank you.
Do I take that as a comment, or do you want to, do you want to leave it for the executive to think about?
Myself, Dr. Mohan Dongre. I'm a scientist from National Chemical Laboratory, Pune. Very interesting presentations by both, because I attended two. I missed the first one. The first was on functionalization of sugar, and second one was on having antioxidants in the brown sugar, other things. My question is that to the first panelist, that does Ikumsa color play important role in your functionalization of sugars? Because you see here in India, we try to bring down the Ikumsa as possible in the sugar mills by doing all sorts of treatments. And second question to Audubon director, that should we go for something like high Ikumsa color? Because in India, you know, we are operating sugar mills using sulfitation process. Whereas we have an opportunity to go for carbonation process because we are collecting so much carbon dioxide from fermentations, and we have that opportunity to switch over to the carbonation process. But you see, the Ikumsa is one of the hindrance for acceptance carbonation process. So I'll be very happy to have comments on both the things, because Ikumsa color, sulfur contents, do they play a very important role for this kind of functionalization of sugar, as well as, because as you rightly said, that antioxidants are important. So by removing the color, we try to remove the antioxidants also. So somehow it is, I'm in dilemma whether I should go for this or I should go for this.
So Ikumsa color is just a measurement of color that we do at pH 7 so that we can relate color for trade. So everything was relative with Ikumsa color, and I made it clear that the refined sugar, we're removing these colorants. Now, sulfitation is a chemical process. It actually converts the colorants, it bleaches them. So it is having an effect on the color, but also the antioxidants. The best way to remove phenolic compounds, the antioxidants, is actually activated carbon, which happens in the refinery. Has that answered your question?
Can I use carbonation process instead of sulfitation process?
Yes, carbonatation is not going to remove those phenolics as much as sulfitation. The sulfitation is literally reacting them and making them non-colored by bleaching them. It's changing them.
Yeah.
Chemically changing them, yes.
Thank you.
Jean-Claude?
And I asked for the functionalization of sugar. Does Ikumsa play an important role in that?
It's an interesting question because we all know that sugar is sold based on its color. It's the standard in trade. It's an indicator of the purity of that sugar. It's what the food manufacturers want. They want a uniform product, as Gillian rightly pointed out. They want a uniform particle size. They want a uniform color so that it doesn't impact on their processing. What Gillian has highlighted is that there are some potential benefits that you may get from different colors. And therefore, that throws the whole current climate or the current process that we have into some disarray. And we've probably got to come up with a different way of explaining what the sugars do to not just the consumer, but also to the end user. So again, it's education. Interestingly, the difference between your polyphenols and your caramel colors and your myide reactions, again, might have an impact. And I still think we're at very much early days understanding where the polyphenols fit in this structure and whether they get incorporated into this complex chemical reactions that give us the color and flavor associated with brown sugars.
Actually, we're quite aware about the colorants in brown sugars. It's well known that 80%, 90% of the color of raw sugars is due to natural colorants in sugarcane. So As I said, sulfitation can affect it though, but carbonation is much less, removing them.
Jean-Claude?
Jean-Claude Autrey. I wanted just to say that, closer. Is it on? Yes, on Thursday, I will present a paper on a study on about 20 types of what we call special sugars produced in Mauritius.
Closer. It needs to be closer, Jean-Claude.
Okay, is it fine now? No. What I wanted to say is that on Thursday, I will present a paper concerning a study of some 20 types of these so-called special sugars, which we produce in Mauritius, which are exported to 55 countries. In fact, the production of special sugars now has overtaken the production of raw refined sugars. And the results are in the direction mentioned today about the antioxidant, low glycemic index, etc. But my point really is, what you mentioned today is that the competitors to sugar are in fact, they base their arguments on what I would call fallacies. Would it be advisable or wise for the sugarcane industry or the sugar industry worldwide to embark on a counter action about the benefits and qualities and virtues of sugar compared to all these things that are in the market, and targeting the young generation who in fact are in favor of these, I would say, of these arguments, when in fact they are not really based on scientific grounds. So should the industry embark on an international campaign? Thank you.
Don't think that. Are we working? There we go. I think it probably depends where you are in the world. I think, so the question is about embarking on a campaign around the health benefits of sugars. I think in Europe, for example, the legislative arena, it probably is preventative of that now. There is so much legislation to prevent claims around things being made on certain products. So it probably depends where you are globally. For me, I think it's around making those campaigns around the functional side as well. So, you know, where it's difficult to do it based on health, you should be looking at functionality and talking to people exactly, as you said, Gillian, around those structural and functional properties, what that brings to food, going back to looking at cooking and how that can be used there to, you know, engage young people in a passion for food and cookery beyond just talking solely about health. Because we know that, you know, that rhetoric constantly around health is not necessarily good for young people. Problems with eating disorders and things now arising with young people, constantly being told what they should and shouldn't eat. So we need to be mindful of those things. For me, I think it's about talking about the types of foods that those sugars are used in. So talking about where sugar has a role in promoting foods that have other nutritional benefits. There's some work we're doing at the moment with Tufts University in the US, looking at how diet quality is related to sugars intakes. And we suspect that where sugars intakes are very low, you actually have lower intakes of fiber and lower intakes of calcium and vitamin D, for example. So in populations where dairy foods are consumed, we know that a little bit of sugar in a yogurt is possibly a good thing in helping people to consume those dairy foods, to take the sort of the sourness away, and that therefore helps to improve intakes of calcium, which is a good thing for teenage bones, for example. So I think it's about having that dialogue around where are those nutritious foods that sugars plays a role in, and swinging the dialogue away from foods that perhaps don't bring such other nutritional benefits with them.
Hello. Hi. Okay. Yes, Richard Nicholson here from SA Cane Growers Association. We're a small industry down the bottom end of Africa. We're also struggling under a HPL, Health Promotion Levy, which is a sugar tax on sugar-sweetened beverages, which is really affecting grower revenue at the end of the day, and impacting then on rural employment in a country with one of the highest unemployment rates in the world. So there we go. But essentially it goes back to what Mr. Jean-Claude was talking about, a global pushback from the sugar industry to really communicate to the public on all these issues. And if we could collaborate using your fantastic research, and thank you for your amazing papers and your presentations, to really create a communication platform amongst sugar industries around the world that are dealing with these taxes. So my question was to Mrs. Eggleston there to maybe ask about the American Association and whether we could collaborate with them on finding ways to work together to communicate the benefits of sugar, basically, in the world. Thank you.
Yes, that's a very good idea. I personally think something like ISSCT could be a good forum, even if it just puts some facts on its website, positive facts about cane sugar and its versatility. Or I'm sure there's other international sugar organizations can do the same. And probably Annie knows more about this than me as well.
Yeah, it's something we look at WSRO. We have quite a specific objective, which is around that voice to the academic community. So people ask me a lot, why don't we do that? Why does WSRO? Because we work a lot with Trix and Priya in South Africa. And so we engage in lots of different international sugar associations around the world. Our role is to generate a objective and scientifically sound voice in the academic community and in some of the organizations like the World Health Organization. So we are quite cautious not to step into that sort of marketing, because that's not our role as an organization. But what we do is provide the research that then international associations, say whether that's ISSCT or others, can then use that very sound and well-respected academic research to deliver those messages. One word of caution I have is around the local voice. I think there's nothing more powerful than a local voice and speaking at the country level to your own population groups, because the way that health is interpreted, yes, we're talking about sugar and sugar's used around the world, but people understand health very differently, and the health challenges are very different in different population groups. So a country like the US, very high rates of overweight and obesity, fairly low rates of undernutrition. Other countries in the world, very high rates, South Africa, India, still high rates of undernutrition. So I think it does have to be done, a tailored message to the local populations, but that doesn't mean to say there couldn't be a global kind of organization behind that, so long as the messages are population appropriate and culturally appropriate.
Thank you.
Hello? For Dr. Denny, no. For Dr. Denny, excuse me, what I have to do? Okay, thank you. For Dr. Denny, you told that the soft texture of processed foods may lead to them being consumed more quickly, leading to higher energy intake rates. My question is, which would be the consequence of doing that, considering that the energy is the same, the quantity of energy is the same? Thank you.
Great, yeah, so it's a really fascinating research area. It's quite new, so it's not definitive. I think there's still lots of questions being asked about ultra-processed foods. So this is just one area of research trying to understand what these mechanisms might be, if indeed there are any mechanisms. So I think they're sort of ruling out the idea that maybe it's the emulsifiers or the additives or other things. The answer to that question is it's how many calories you can consume. So if you eat quickly, so if I ask you all to start eating your lunch now, and I ask half of you to eat really quickly, you'll eat more calories and then you'll probably go back for seconds. Whereas if you eat slowly, you only have time to take the one portion of food. So speed of eating is related to how many calories you consume in that amount of time. So the amount of calories in the food is the same. You're all having the same food, but those of you that eat faster take in more calories. So that's what we think possibly happens, and it could be the case in a sugar-sweetened beverage. It's quite quick to drink a can of soda. You can do it quite quickly, and that's possibly part of the problem, is you don't then get that sensation of fullness. If I ask you to go and eat a whole plate of vegetables, difficult to eat those quickly, and they'll make you feel fuller at the end, so you probably have fewer calories. So that's why it's an interesting area of research.
We're running out of time, but we've got a question there and another one there.
Myself,
And they are the last.
Nowadays, we are talking about the organic sugar. So how it differs from the other sugars, and what are the reasons to prefer it as a diet?
Organic sugar is an interesting concept. You actually have to go back essentially to the fields where the crop is grown. So that's the fields for sugarcane, the fields for sugar beet, and grow in an organic way. Organic appeals to what I would call the worried well, where you actually have people that think that organic is better. We know full well that probably organic is a good way to grow, but it doesn't give you the same yields, it doesn't give you the same product, and the benefits you get are probably not completely justified by the way it's grown. But organic is important for a lot of people. So again, you'll tend to be focusing on a certain part of the population. Organic sugar is difficult to make. We know that, both cane and beet. Certainly British Sugar and several other companies have tried to make beet organic, but the major problem was getting the fields to grow it and then keeping it segregated in the process. So it is a challenge, and you don't actually get the benefit back. So personally, I don't think organic is the way to go. Understanding what we have within our product is a far better way of going.
Yeah, Narendra Mohan from National Sugar Institute, Kanpur. As you know, in India we produce only plantation white sugar. By and large, we produce plantation white sugar and we use it for domestic consumption also. But from the last couple of years, there is a debate on whether we should consume the raw sugar also. Because already in the presentation we have seen advocating the brown sugars or the other sugars which are more natural or having less of the processing. So I would like to know from Gillian or from Annie whether we should go for direct consumption of the raw sugar also in place of the plantation white sugar. It is going to do something good to the health of the people also.
It's all going to depend on demand, on consumer demand. It's probably certain sectors are going to want the white sugar or the plantation, the large volume, cake manufacturers or whatever. But when you're selling it maybe to the local consumer, maybe they don't need it so white. I think it's all going to be demand driven. And I don't know the demand in India, so that's something you need to discuss here.
Well, certainly the brown sugars, and my experience is from the UK, and Billington's, again, were part of the Associated British Foods Group that I used to work for. And certainly they had a higher premium label, but it was mostly in the retail sector, so people using that in the home. The commercial people wanted the uniformity. So the way Julian explained the reconstructed brown sugars, where you would take white sugar and mix back some of the cane refining syrups or molasses to give you a uniform crystal size, a uniform color, so you could then produce the products that they wanted to on a large scale. If you're looking at artisan bakeries, they may well want the real nature and the story behind the product, and they are able to value that and pay that premium. So it's where you want to go, but certainly there's some interesting opportunities there for the brown sugars, certainly from a taste point of view and also a provenance point of view, which people are valuing.
Right, last question.
That means...
Put the microphone up to your mouth.
I'm Sharma from Uganda. Hello. I'm Sharma from Uganda. That means the refined sugar with a low ICMSA color, like 30, 40, 10, it goes in the background as compared to very, very high pole raw sugar with 800, 900 comes a value, which is easy to make. Why make white sugar and then spray molasses, which is complicated?
If you can guarantee to get the same color and the same particle size from crystallizing from a cane syrup, then the commercial users will be quite happy with that. However, we all know the variability in the color through the process, the variability season to season to get that consistency is quite difficult to achieve. You can do it if you are doing it to white sugar. You will get a consistent product all the time because of the low level of impurities. As you increase the level of impurities, it increases the variability far wider than a commercial company would want to pay. So again, that's the only reason why you use the reconstituted brown sugars, for want of a better term. You can guarantee that color time and time again, and it's the quality control and the consistency that certainly commercial users want. The artisan bakers and the home baker is quite happy to take that variability. They're not actually producing a product that has to get into a pack. For example, a biscuit manufacturer wants to get the same number of biscuits, the same size, all the time. They want that consistency, which I don't think can be achieved. I may be proved wrong.
Okay, we need to stop the questions here. The presenters have given us a lot of information that we need to take away and digest and think about the future, how we can promote better the benefits of sugar. Perhaps the most immediate takeaway message is go and enjoy your lunch shortly, but then work off the calories by walking through the trade display areas. Now, I understand there's a presentation for the presenters.
Hello. So thank you, Mr. Chairman, sir, for chairing this important session. And I also take this opportunity to thank all our distinguished guests who have come from especially for this session, and all the delegates for the valuable follow-up questions. So as a token of appreciation and gesture from COC, I request Mr. Sanjay Vasti, President, Executive President, to present the mementos.
Please brief. Chairman, sir, first of all to you.
Just a couple of more points. Firstly, there is a plenary session on organic sugar, which is when, Bernard? Tomorrow. Tomorrow, the plenary session is on production of organic sugar. Tonight, the cultural night starts at 7:30 in this hall here. Okay, thanks. Go and enjoy your lunch with just plenty of sugar, sucrose.